This is Module 14F, and it's going to be our discussion, very brief discussion of one resource, selective dedication of certain resources that we need. In many organizations, we spend a lot of time with different processes, so each one of these lines represents a product family that we're making, and we've been able to balance the line, and you see that we got regular intervals of time all through here. This one runs a little bit slower, this one runs a little bit faster, this one runs a little bit slower yet. But they're all balanced and they're all even. But at the end, they all have to go into this one shared resource. Maybe it's a plating operation, or maybe it's some finishing operation. Anyway, it's one shared resource. So when we put all those things together, the shared resource doesn't have a nice smooth flow of things coming into it. So how do we handle that? Well, what we usually do is we put buffers all over the place. But this principle of one resource means if we can, we want to duplicate the capability of that resource and dedicate it to each one of those lines. So it doesn't have to be the same resource as the shared resource, but it has to serve the function that each one of those product families needs. And notice that we've moved these all, just integrated that duplicate resource right into the line or the work cell. In this case, it's still a shared resource, so there might be some other capacity that we want to fill by other places, so we might still buffer that a little bit, and that's what this kind of symbolizes. So what's our shared resource in the Yeller Promotions simulation? Well, it's the stapler. Now remember, I told you earlier that the stapler isn't really a stapler. It represents a very expensive piece of capital equipment, and that you couldn't get one unless you go through the process for getting approval of CapEx, or you have this influx of money or something like that. And so I told you in round 0, in the very baseline round, that we were approved to buy one, but we wouldn't be able to get it for 3 years. Well, we're not quite at 3 years yet. But we've started doing a lot of other lean stuff in the organization. And one of those things that we do pretty regularly now is that 4S or 5S that we talked about in one of the earlier modules. So we organized the workplace and we cleaned up a little bit. So we tend to go into nooks and crannies of the facilities when we do those kinds of activities. And every facility that I've been in, they all have this one section of the building where they keep all the extra stuff. It's like we're hoarders. We don't throw anything away. We just kind of stick everything over there. So it just so happens that if you go in there, the chances of finding a piece of equipment that's old and no longer used because maybe we bought something new to replace it, we still have the capability we need. It might not be as fast, it might not be as perfect or anything, but we can still use that resource and dedicate it into the work area. And so the storyline for the simulation is that we found a stapler that was old and it's a little crusty, so it needs a little maintenance, but it only does innies. It only folds them in. And of course, that's what we need for the OH product. The IO product still needs them to go out. But I can use both of those staplers now and dedicate a stapler to each one of the work cells. So here's your challenge. I want you to act as if there's a second stapler, and then I want you to embed it in the cell and rebalance the work cell. So rebalance the work in that cell, but here are the key rules. You can only have 3 operators in the work cell. So you can't take one of the 2 stapler guys and throw them in the cell and just have a staple operators and the clipper. You have to keep the clipping function. I know you want to get rid of it, but you can't. And we still have this rule where 1 letter per writer. And the main reason for that, again, is the number of decisions that an operator has to make in a work cycle is directly proportional to the number of mistakes that they're going to make. So if we can reduce that, if they don't have to choose, do I have to write an O or an H or an I, we don't want them to have to make that decision. You're always making O's, you're always making I's, as long as you're in this particular workstation. Okay? So pause the video. Well, not yet. Here's what you have. Okay, you've got the table space. You've got 3 operators. You've got some blank cards. You've got an O writer and an O writing output Kanban, an H writer and an H writer output Kanban, a clipper with paper clips and a Kanban. You've got a stapler and an output Kanban for the stapler. There's a few more blank cards, and then the input for blank cards for the O and the H. So just focused on the OH work cell. Play around with this and see if you can come up with a layout that you like to get smooth flow in single piece all the way through, following the rules that we specified. So pause, play around with this a little bit, and then come back and I'll show you the school solution. Okay, I'm back. So this is the school solution layout, and it isn't perfect, and it's not the only way to do this by any stretch, but I've found that this works really well in almost every group. So I have a bottom letter writer. Okay, so the first thing I ask people when we do this is, what do you want to do first? And they usually just want to give the stapler to the clipping person. Well, is that a good solution? The clipping is the longest cycle time operation in the work cell. In other words, it's the bottleneck process. You don't want to give it more work. You want to be able to relieve some of the work from him or her. So the writing is the fastest. So we can give more work content to the two writers. And it works out that the H on the bottom takes a little bit longer to write than the O on the top. And so we thought it might balance things out pretty well if we had the H writer stack a blank card on top of the H and put it in the Kanban for the clipper to pull and double check the alignment and put the paper clip on, and then put it in an output Kanban for the O-writer / stapler. And the sequence that this person has to follow is they will pull the card set from here into their workstation, remove the paper clip, staple it first because it's aligned, right? The paper clip is there just to preserve the alignment. So they pull it into their workstation, staple it, then they have to remove the paper clip, and then they write the O, and then they put it in the output Kanban. It's a complete product. Why is that sequence important? One, the stapling has to be first because we don't want to risk losing that alignment that the clipper invested so much time in. Two, if we don't remove the paper clip, we risk hitting that paper clip when we're writing the O and causing a defect. So we want to minimize the chances for defects. Another thing in this round of the simulation is I only let them have like 4 paper clips. And so the stapler, when they remove the paper clip, they have to send it back to the clipping station. So there's a lot of interaction between these two workstations. If you've got something different, put it in a note, put it in the discussion board and share it with us, and let's see what we can do. I'll show you the typical results that we get. My animation hasn't come through yet for this. When it does, I'll re-record this, and you can see the actual video of people working in this new layout. So if we do both tables the same way, you see they're kind of mirrored. So we have the paper supplier is going to come in and still runs a milk run, hitting both workstations, and then the flow follows both, and then we'll have somebody coming picking up and counting. Okay, and here's your typical performance. Now in this case, in the 2 cells, we have reduced the total inventory from 16 to 8, and based on what I told you about throughput time, we should expect the throughput time to be roughly half of what it was in the previous round. And sure enough, that's what we got. So in this case, we had a little performance glitch, and we finished with 9 cards instead of the 8 that we started with. And that's fine. That just tells us we've got a problem someplace that we need to go and see. So I need to go and find out what happened in the H writing place to see how they ended up with an extra card. Chances are the operator pulled the H in before the clipper pulled from the output kanban. And I said, while we run the simulation in a live audience in 90 seconds, I went ahead and doubled it here, so we had 180 seconds all the way across. In this case, they only got 60 cards out, so our output actually went down. What do you think happened here? Well, we've actually deliberately slowed down the production, haven't we? We set the takt time at 6 seconds. We only wanted 15 orders. So we got 15 orders out of each table. So that's 60 cards. So we fulfilled all of our orders on time. Our effective cycle time per card is now 3 seconds. So it went from 2.3 in the previous round to 3 seconds. So it's a little slower. Our throughput time dropped from 38 seconds to 18. So is that consistent with what we've been talking about with the inventory levels? Yes. Now we got 8 people. We've only got 3 in the 2 work cells, but we also have 2 kind of leaders. We've freed up a lot of people. We've freed up 6 people from the very first round. But we didn't fire anybody. We had them all training or doing something else, and some of them might be leaders, and some of them might be industrial engineering folks, and we've got all kinds of things. But what I'd really like to see us do is launch 2 new products, because now we've got enough people to operate 2 more cells, since we got 3 people per cell. Where are the staplers going to come from? Well, we'd either have to use shared resources again, maybe 2 cells for each stapler, or since our cash flow is in pretty good shape now, maybe we can buy a couple of staplers. I say the cash flow is in good shape, but again, we are less revenue than the previous round. So in a lot of cases, people would just say, wait a minute, this isn't working right. But if we look at how the system functions and our capability, and if we put 2 more work cells to work, we can effectively double that right here with the resources that we have. Those are the kind of decisions we want to be able to make. Based on the numbers that we have, can we get those analyzed and make better decisions? What are the kind of conclusions can you make based on these numbers? Let me know what you think. And there's the written version of all the stuff I just said. Now here's your next challenge. We want you to do the work at takt, okay, so 6-second takt time, but I want you to reduce the number of people in the cell to only 2. Okay, so the rules, 2 operators per cell, again, 1 letter per writer. Now you can get rid of the clipping function, but you can't, once you get the cards aligned, you have to feed them straight into the stapler. So you can't let go of them once you've aligned them. That's the only key thing. So how do you do this with 2 people? I just let groups kind of explore with this, and we try all kinds of different things in classes. See what you can come up with. Generally speaking, they get a little bit more output. It's a little bit more stressful because there's only 2 of them, but it doesn't seem to overwhelm anybody if we keep working at that 6-second pace. So in Module 14, we talked about flow and pull. This was our 1 pace and our 1 resource round. We talked about the performance of the 1 piece round, that when we dropped the batch sizes down. We talked about demand variability and work scheduling by a Heijunka. Now, if you want to know more about Heijunka boxes and all that good stuff, one of the best resources that there is for level pull is this one, Creating Level Pull by Art Smalley. Okay, this is available from LEI. This is a great little resource to have on your bookshelf if you're going to be doing some of this. Or if you're managing people, you might want to get a few for your folks so that they can make better decisions for you or give you better information so you can make better decisions. We talked about the principle of postponement. I showed you my little Lego engines. And we talked about pacemakers and the difference between a pacemaker and a bottleneck. And then we went into the 1 resource where if we can, we want to dedicate resources, and that should allow us to stabilize things and get better balance and create a more satisfying work environment. can't always duplicate the same capabilities because, you know, equipment is expensive when it does multiple things. We just want one tiny little thing. While I'm thinking about it, one great example of that dedication occurred at one of the suppliers of instrument panel components for dashboards in the Toyotas. This company used to have a huge room for powder coating, essentially painting. So they would make all these component parts, all these different plastic and little metal parts that they would bend, and they would assemble them into things, and then they would send them off to be painted. So they'd have to go through and wait for this single shared painting resource and the color changes and all that. So there were all long delays. So instead of investing in huge amounts of environmentally secure big paint booths, what they did was they invented a small paint booth with an appropriate EPA approved ventilation system. So now they have a paint booth at each one of the cells that focuses on maybe the air conditioner vents, maybe the any other panel that's on the dashboard or the instrument panel. So when they have to have it painted, they've got a dedicated paint room just for that component parts, and it's dedicated by color as well. So they never have any changeovers for colors. And it's right there in the cell. Somebody just paints. They have to teach a few people how to paint. That is probably one of the best examples of dedicating resources that I've ever seen. And that's going to wrap up Module 14.